We're live.
Oh, we're live.
We are.
Hi, Shawn.
Hey, what's happening, guys?
Hey, Joe. I don't know what else to talk about. When we first start out, like we could have small.
Good morning, everybody. I know. I just welcome everybody for coming. I know people are still filtering in. I hope that people are still filtering in. That we're not just here talking to ourselves. But if you are on, say hi. Post in the comment box. We'd love to hear from you.
Hi.
And
you weren't talking to me. My bad, Joe. Sorry.
No. But let's.
Where's everybody from?
Oh, that's a good one.
Where are you joining us from? Just say hi. I mean, for most of you that don't know, on LinkedIn Live, we can't see. There's Teddy. Actually, want to address that, Chad? Hey, guys. Hi, Teddy.
Yeah. You mean the fact that we can't see anybody typically?
No, Ted.
No, the fact that Ted's not with us.
Yeah, Ted's not with us today. You made it, Shawn, you made it sound worse than that. Ted's not with us.
Ted's double booked.
Ted's double booked. Ted was going to be on, but he's actually at lunch with customers, and he gave it a good old valiant try, but the waitress in the background kind of killed it. So
yeah, tried to order some chicken wings and beer.
Teddy says he's in Buffalo. All right, let's get started. Chad, you want to tell everybody what we're doing here today?
Absolutely. So today we're gonna talk. We're gonna do a little gasket 101 essentially with Shawn Bower from Lamons. Shawn's been in the gasket industry for over 20 years. He's a wealth of knowledge. He's done a ton of these educational things for us. He did some in the expo. He's traveled around with a lot of the Upsco guys doing the flange assembly demo unit, which is also affectionately known as the FADU. The FADU, and so. We're just looking to educate here. We want to teach you guys about gaskets and the proper use. And other than that, I'll turn it over to Shawn.
Yeah, we're like we did last time, Shawn. Just really quick, we have a little PowerPoint that you put together. It's just something that we're going to talk along with, kind of just to give some bullet points and talking points, and also some pictures because everybody loves pictures. So I'm going to share this really quick. Hopefully everybody can see. There we are. As we said, I'll turn it over to you, buddy, and we'll.
Thanks a lot, guys. I really appreciate you having me here on this live presentation. It's kind of a first for me with going live like this. Except for
just don't say bad words, Shawnee.
That's right.
That's all you got to remember.
I'll try my best.
Thank you.
But under the certain circumstances here with COVID, it's going to be a challenge. So, anyways. So as Chad and Joe mentioned, this talk is a little bit of an informative talk on flange and gasket installation and so on. Some of the challenges that you'd be facing out in the field and such. The first slide here just more or less kind of gets down to it. You have to understand that a gasket provides seal that allow two flange components to be separated. Gasket needs to be able to overcome minor or major flange imperfections, distortions, scratches, and so on. Many known variables that can affect the joint's ability to maintain a seal. You must understand that a leak is not an indication of a faulty gasket, but an indication of the integrity of the joint, right? So when you're looking at gaskets as a whole for your application, there's a lot that is involved. It's not just a regular old blue gasket that goes into that flange to seal it up. There's a lot more things that are involved. So,
Shawn, I just want to touch real quick. I think a lot of times you're right. In our industry, a lot of times when people see a leaky joint at a flange fitting, they automatically blame the gasket. And a lot of times, and most times, it's usually not the gasket, oddly enough. It's typically installation or torque, how they torqued it down, something like that. And I know you're going to get into it, but I just wanted to talk a little bit about it too. That's all.
It's more or less, it's a lot of the times it's turning to the gasket and it's the gasket's fault, but that's not essentially the truth. So go ahead, Joe.
Yeah, well, let's get in and talk about like styles of gaskets and some of the things that that you might see out there?
And Shawn,
yeah.
If I may, just break it down pretty simply, please. Just if you can, as simple as you can make it for the different materials, like you did for me when I started trying to do these things.
Yeah. So really, when you're looking at the application, there's a lot of things that you need to look at: your media, your temperature, metallurgy of the flange, components, fasteners, and so on. It really plays a big part into what material goes into the gasket and what style of gasket, either a type E or a type F. Type F being a ring face, or type E being the full face. Be it a raised face flange or a flat face flange, and so on. Really, plays a big part on the material that you're using, the style of gasket, and so on.
Sure.
So really, when you look at it, each flange, each pipeline has its own identity. So, and that really dictates how and what gasket you're going to use and the material used and so on.
I think another important thing is the application, right? I think there's a lot of different gaskets out there for so many different applications, and I can kind of get lost in that. But let's just kind of talk about, the application methodology behind the gaskets.
Yes. So, you might be dealing with an exchanger unit or isolation, or being a below grade application. You might be in, elements up northern Canada, dealing with those things, and it really plays a part on the material. And even the lubrication that you use for your fasteners plays a big key part into the torque applied to the fasteners for that gasket in order to get the proper clamp load. So when you're dealing with all these different types of scenarios and applications, it really plays a part on the type of gasket used.
I think there's some, like we talked about this earlier, but the basics, Chad wanted to talk about just what you need to know when you choose the gasket for the application that you're looking at.
Yeah, that's kind of what I was looking for. Thank you, Joe.
Good point. So the basics, the very basics, when they call into their shop, it's, we need to know the temperature, media, national pipe standard, and the ANSI class and schedule. All of our gaskets we recommend to monitor what schedule, be it a schedule standard, 40, skid 80, 120, or so on. We want that gasket to meet to the ID of that flange connection. But also, there's other applications that are out there, be it isolation, or if it's a meter, below grade, style of flange, and so on. Those are kind of the things that are missed a lot of the time. But the very basic information that we need is the temperature, media, size, class, and schedule.
Shawn, and this is just a question completely just from based on what you said, how many below grade gaskets do you see used? I mean, I don't think we see a whole lot in the gas utilities used that way.
Yeah, no, there's not a tremendous amount, but a lot of the times, companies will tie into certain areas, what have you, and they might need to isolate those areas. So, an isolation gasket kit is needed in those
or an MIJ, I would assume, right?
That's right. Yeah, 100%.
Gotcha.
So,
okay.
When you're installing a gasket, when you're looking at procuring a gasket for your flange connection, you have to understand what that gasket is going through. There's a lot of forces that are involved when you're clamping down that flange connection. You've got your clamping force on the outer edge of the flange, but as well you've got internal forces and thrusts and so on that's taking place. But as well too, you have to understand when you first install the gasket, there's a relaxation period that happens when
that's my favorite part.
Yeah. So, there's cases where some gaskets can relax up to 40 to 50% of the actual compression load on the gasket, depending on the material and so on. But, operators need to understand that a relaxation period happens. So it's highly recommended to go back and retorque at 100% after install. About a 24-hour period.
I think that brings us to our next slide, which is, if it has a leak, what do? You tighten it up. And I think that's part of what you're just talking about. It could be relaxation of the gasket. It could be several things, but.
Yeah, a lot of the times we're faced with, questions from the field if there might be a leak or an issue either after hydro testing or, basic install. And if there's a leak, we're faced with the question, well, can we just tighten it up, go past the recommended torque? Well, I say generally no.
Well, you can. It's just not going to do anything, right?
That's right. Let's get to the root cause first of why that flange, why that gasket may be leaking, and come up with a a plan. So the basic questions you really need to ask to get to that root cause failure is who's the manufacturer of the product. Generally, might not be our gasket, but we want to help. Where did the gasket product come from? Could be an old gasket, could be a new gasket, could be a retrofitting application. Who knows? Were all torques met to manufacturer suggested torque values? Do you suspect the gasket or installation? Because sometimes when you're installing a gasket, if the gasket is lowered in from the top, maybe the seal of the gasket, if it's raised out from the retainer of the gasket, it might get caught up on the raised face portion of the flange and get locked out or what have you. Were the flanges correctly spaced before bolt up? Are the flanges correctly spaced now? And did they check? Those are two very important keys that need to be followed. And do you have adequate gasket compression, retrofit application, and so on. You guys can read the slide, but it's important that these fine questions are asked and answered correctly. And if it's if we find out that there's an issue here, then we can generally get to the root cause.
I have a question, Shawn. Out of all those questions, what do you see the most is typically the failure, at least in your opinion, that comes back where that is the problem?
Gasket compression, not adequate.
Gotcha.
Where the spacing of the flanges is exceeds the proper amount, or uneven compression, and so on.
And all that is really what you're saying is installation.
Absolutely.
Yeah.
And I think that there's some standards out there if you want to run through them.
Whoa, you're like a ninja today.
Whoa, holy smokes.
You are like a ninja.
Firing on all cylinders.
The dress shirt. It's the dress shirt.
I know. I comb my hair and everything.
Yeah. So ASME has certain guidelines that we more or less go by out in the field, and that we recommend as best practices. And if a lot of these guidelines are followed, you should not have a problem. So excessive gap, number one, is greater than twice the thickness of the gasket. It's too much, right? Anything more than that, you're not going to get the clamp load that you need on the gasket to create a quality seal.
Sure.
So it's
so you just put in two gaskets.
Yeah,
The sales guy.
yeah. But ASME, they recommend before, during, and after when you're doing the torquing sequence, to measure 8 separate points of the flange connection, to measure that gap, to ensure that you have adequate and even load on the gasket at different points of the flange.
Yeah, I joke about that because as sales guys, we'll put 4 gaskets in there just to make sure.
Yeah.
They double up on this.
How many do you want?
I know that this is something that I've heard you talk about in the past, is just inspecting your gasket. I think is a potential issue or root cause of failure. I just wanted to kind of touch on that, if you wouldn't mind, as far as what to look for and what people might see out in the field.
Yeah, it's important. So if you experience a failure, first, don't touch anything. Generally inspect the flange with the gasket in it. Do your make sure you follow the proper torques and so on. Measure the gap. flange to flange. Make sure your gap is adequate, and then unbolt that flange. Take your gasket out and inspect it. Take a look at the gasket. It will tell you a lot of things that you need to know about that connection, and generally can lead to the root cause. You'll see the gasket on the far right there. That's one of our isolation gaskets. Customer called, said that they had an issue with gas bypass, and it turns out that when you look at the gasket and the retainer of the gasket, there should be markings, RMS markings on the retainer, which are just grooves along the retainer, and there was none. So that right away tells me that they didn't have adequate gasket compression on that. So, and you should see markings on the seal, and it should be compressed. But you can see in the middle picture that gasket, easy to determine, chemical attack on the gasket. So
gotcha. I know that we've talked about this is a big thing, is that everybody thinks that when the flange is leaking or there's a problem, you should just crank it down.
That's right.
Make it tighter, right?
Tighter is better and so on. Yeah. But you'll see big guys out there out in the field with 6-foot pipes, honking down on the fasteners and so on. That's just not the way to do it. So you really need to follow ASME standards and recommendations, and you'll see kind of on the next slide here.
Yeah, I was going to bring that up.
So there's lots of tools out there, but honestly, guys, just a basic measuring tape, caliper gauges, or we have our flange measuring devices there. You can find it in the back of the truck usually, or what have you. Just measure the flanges, making sure you have equal load on different points of the flange.
Shawn, are there any devices out there that are like digital that you can affix to your flange to be able to calculate actual torque or compression? Is that something that exists?
You know what? That's a great question. A lot of the times, customers, they wouldn't essentially go for that because of expense and such. But right. there would be, like we do with our FADU machine. We have our compression gauges and such connected to that, which shows load on each fastener and so on. There's also our fasteners that have load indicating studs. That can be applied to the flange, but that's where you're getting up into the
cost,
and so on. For the majority of the applications, it's not really needed.
I know that we've seen this is a big problem, is specifically like misalignment. People want to do our little off kilter and they don't really line up straight, and they just want to. I know that for per ASME that's a pretty big no-no, and I just wanted you to talk about the tolerances and what to look for.
100%. So you have to understand is when you're putting forces like this on the pipeline and they're misaligned like this, puts a lot of undue stress on your fasteners, on your gaskets. When you're bolting, this type of flange up that's misaligned. If it's a isolation application, you're not going to be able to get the sleeves through both sides of the flange and so on. It's just unneeded. So, kind of a good rule of thumb is to take a look upstream, downstream. If you can loosen off, a couple of flanges upstream and downstream to kind of center this one flange that you're having an issue with, that's usually generally the way. Don't hook on to one of these sides and try to get a come along and try to square it up. That's just wrong. You should take a look upstream, downstream and loosen off.
it really makes me respect the fact of, you know, I've been on a ton of job sites, even in the transmission world and the midstream world, where these guys that are putting this stuff together, these welders and these fabricators, literally have to be accurate within half an inch. Like it's absolutely wild.
Yeah, 100%. And you have to, you know, understand too that, you know, ground movement, it's not essentially their fault.
Right.
It's, you know, ground movement or what have you. You know, a lot of these areas, the compressor stations and what have you, it's just all, you know, crushed rock and
that's crazy.
You know, and fill added in, and then, you know, things, you know, kind of relax and settle in. Well, you know, the hard work that they, you know, did, you know, results in, you know, misaligned flanges and such. So there are you know, ways to get around it, but you just can't hook onto it and bend it in shape and center it, and yeah,
muscle it in. Yeah. I wanted to bring up this too, because we talk about this a lot with meters or pumps or valves and things that are, you know, I think when we talk and we're thinking of flange to flange connection, which is really, you know, really also, it's important, but there's also products that are flange that we bolt on that have a little bit different challenges, per se, because of those things. And I know that we talked, I wanted you to just address the meters and potentially other items.
Yeah, so when you're looking at, you know, a lot of the time cast iron flanges, which require less load because of the limitations of the metallurgy, you can't just tighten it up for, you know, your regular standard iron flanges. You know, it's you have to be careful with these, and then when you're bolting them up, you could easily rotate these flanges and cause cracks, breaks, what have you. So when you're contacting, your customers are contacting you guys, making sure you need to understand the metallurgies and effects. So you need to go with a low compressive load gasket in order to seal these properly, and so on. Gotcha. So if you're just tighten them up, your regular, you know, standard flanges, you're going to rotate them and could, you know, damage the pump and so on. So
yeah, moving on. The other thing we talked about a lot are we
Sean.
Sean left. The beauty of being live.
Had to let the puppy out.
No problem. No problem. I want to talk about parallelism, because that's something that we see quite a bit with things that are not necessarily, you know, we talked about
that.
Yeah, that's why I said it.
Yeah, so you know, it's much the same as you know, the offset flanges and so on. You know, it happens, right, when you're dealing with new construction or even old construction, retrofitting applications. It's when you've got this type of scenario, you really need to take a look upstream and downstream to see if you can loosen up the flanges to try to get these true again. You know, and that's kind of the best way, because if you just go ahead and tighten up the flanges with the gasket in there like this, well, you're not going to get proper load on the gasket in, you know, that kind of localized area, and that's where you'll experience your failure, essentially. Also, you could be damaging the gasket on the other side, where it could be pinching the material and so on. Plus, also, you're putting undue stress on the fasteners and also the flange. So it's not. I mean,
this is a really great way to crack a flange. You know, to be able to over torque on that kind of deviated side. It's that a cast flange, especially on a meter or even a valve or something, could that'll just disintegrate.
100%. Yep.
So other items we talk about is flange flatness. Flange flatness. That's hard to say.
Yeah, so, you know, you take a look. You know, ASME has some recommended, you know, areas here, but you know, when you're talking about flange flatness, you're looking at corrosion, steam cuts, you name it, dirt and what have you. You know, residue from previous gaskets being in place, what have you, graphite, whatever it is. It's important to make sure that you take a look at your flange faces first before you install those gaskets. Even if it's a brand new application, if those flanges have sat in the boneyard for a year plus waiting to get in, to be installed,
right.
Things can happen, right? Corrosion can develop, mill scale, and so on. That affects the sealability of that gasket. So it's important to take a look.
Yeah, I think also, and moving on to the next slide, is the flange finish. That's
always
something.
a big one.
That's something we don't talk about enough. I think a lot of people, and we see this sometimes in fabrication facilities, like where we're actually, like with Upsco, for example, where we have to be careful that we don't wheelabrate or blast off the finish of the flange. So I want to definitely touch on that because it's very, very important and something we see frequently.
Yeah, so it's important to clean your flange face with a mild abrasive rotary disc, what have you, to clean off that paint from shipping and so on, but also mill scale as well. It affects that RMS finish and so on. You see that mostly on cast flanges, but also in meter sets and such, overspray, paint overspray that develops an uneven coat on the flange, which again can affect that sealing surface.
Shawn, what does RMS stand for?
Root mean square. It's the flange finish.
Forget I asked.
Yeah.
So basically, for those that don't know what that is, if you look at correct me if I'm wrong. If you look at a flange from the side, there's little teeny grooves in it, almost like little waves, and that's what helps grab that gasket. Correct?
Yeah, 100%. Yeah.
Okay.
It's little tiny teeth basically that grab on to the material of the gasket, the retainer of the gasket, and little tiny seals get in there, and then the material of the gasket retainer cold flows into the RMS, creating a nice tight seal.
What was RMS again?
Wait a minute, stop. I was gonna ask Chad if he could tell me what it was.
I don't have no chance.
I think it's on the next slide. Go to the next slide, Turkey. No, it's not there yet.
Oh.
But anyways, what things that gaskets cannot do, as we kind of went through, cannot correct warp flanges, compensate where misaligned flanges, seal where there's excessive damage, excessive gap, and so on. Don't be applying two gaskets like Chad, not Chad.
I didn't say
Joe.
that.
I know. Joe said, and there's no real wonder gasket out there. You have to understand there's a lot of different applications out there, a lot of things that these gaskets need to overcome. As long as we know those things, then we can supply you with the proper gasket for that application.
Hey, Shawn.
This is a picture here where I was down in Louisiana, where there were sort of large LNG train, new application, and they had some issues with some gaskets, and they called me up and told me they were leaking at hydro and needed some help. Well, I was asking my standard questions, trying to get to that root cause, and they said, well, the flanges are brand new. There's no issue with the flanges, and I started questioning the flange surface area and so on. And they were right. This is a brand new construction, brand new flanges. But what they didn't tell me was that these flanges sat out in the boneyard for a year plus.
You can see
developing that corrosion, and it affected the sealability of the gasket. So what I did was, this company spent a lot of money on isolation gaskets and so on. These areas need to be isolated. So what I did was, there was a flange refinishing crew on site. I said, guys, refinish the flanges if you can. The next day we installed the gaskets, passed with flying colors.
Wow.
So I was able to go out there, essentially look at the applications, see the gaskets, take a look at the flanges, and then essentially save the company, thousands of dollars on, reusing the gaskets and get them back up and running.
Hey, Shawn.
Yeah.
What's 7 and 8?
What? Oh.
Doesn't it usually go 7, 8, 9? I didn't.
I don't know if that's the Canadian counting system.
I'm Canadian.
Yeah, I'm Canadian. Sorry, I just had to point that out. It was perplexing me. So there's some other things. We talked about the RMS and flange finish. So let's just dive into that a little bit more quickly for everybody. I know we're kind of getting long in the tooth, but let's. I did want to touch on this a little bit.
All recorded too.
So when you're looking at the RMS, us as a gasket manufacturer, we recommend a 125 to a 250 finish. Now, what that means, it's the differences between the peaks and the valleys of the raised areas of the flanges. So,
Shawn, it's almost like in corrosion, getting that surface profile. It's almost the same thing. Just giving it something to grab onto, essentially.
Exactly, 100%. Yeah, yeah. So if there's anything, paint that operate or manufacturers use for shipping, blinds or flanges or whatever, they paint them to for corrosion purposes, right?
Sure.
So they don't develop a mill scale. If that paint isn't removed, well, that paint actually fills in those spots.
And it probably sticks good too, which is funny.
Yeah,
it probably actually sticks really well to it.
Shawn, I have a question about like for our industry, for like natural gas industry, and the flanges and the things that we typically use. Where do most flanges fall with what? Like, what's the traditional finish that they come from the manufacturer?
125.
So that's like the standard.
Yeah.
Okay. All right. I was just curious about that because people know what to look for. The other thing we talk about too is what is the right material? There's so many different types of gaskets out there, from your paper, fiber wound, phenolic, spiral wound, fire safe. There's millions of them, and I know that we see a cross section depending on the medium, depending on a lot of different factors. But let's just talk about how to select a material that's right for your application.
Right. So like if you're looking at, let's say a rotary flange, cast iron, and flat face. So if you're dealing with, that kind of application, you want a pliable gasket, a gasket that creates less resistance, low MMY values, and can compress quite easily, so it'll seal up. Generally too, on those cast flanges, the surface area is quite rough, right? It's not a fine finish. So again, you want a pliable material that will be able to cold flow into those anomalies on the flange face and create a nice tight seal. Sometimes, in the industry, as we pointed out, there seems to be a lot of wonder gaskets out there. Your standard blue gasket that goes onto the meter set and so on. But you know what, you really need to take a good look at these applications and listen to the operators out in the field and get a good understanding from them. Chances are, these gaskets are not the right for their application. And I've seen guys having to put pipe dope on the gaskets so they don't stick to the flange faces, or they have to dunk those gaskets in water to make them a little bit more pliable and so on. There's other alternatives out in the industry for gaskets that can really, help operations out and get you up and running quickly without problems, right?
And not some significantly crazy amount of money difference.
Oh, absolutely not.
Which is the amazing part. I mean, that's the amazing part.
I wanted to talk about, we actually have a question that I'm going to post here in a second for you, Shawn, but one thing I wanted to touch on this is I think in today's day and age, specifically, we're really looking at trying to reduce emissions and lower our carbon footprint and methane and loss and all that thing. And I think by just utilizing the proper gasket, we can help reduce. I mean, it's those little things that we can do as an industry to be able to reduce the amount of emissions that we have. And it's using the right gasket or properly sealing something to reduce any potentials for leaks. So I just want to focus on why that's so important. It's not always necessarily buying the $1 gasket versus buying the $3 gasket. It's about, a bigger picture than that. So I just wanted to toss that out there.
Yeah. So you take, here's an example for you. Phenolic material has been out in the industry for so long. It's one of the industry's kind of first isolation gaskets. Okay. And it's been used time and time again. Phenolic material is basically compressed paper with adders and fillers in there to solidify it. And in areas, say in a natural gas area, where you might have a high water cut. Well, what will happen eventually is phenolic material has a high water absorption rate, and now that system with a high water cut will collect itself into the phenolic gasket, and eventually that phenolic material will become brittle. And fail. But also compliance-wise, it will not isolate properly because you have that water absorption, and it's going to arc out on both flanges. Yep. So, an alternative gasket would be, our CPG gasket, which is a little bit more pliable gasket, but it's a PTFE-based material, or the glass reinforced epoxy gasket, which is, kind of your industry standard now isolation product. So with very low water absorption rates and so on.
Like I said, Shawn, we have a question here from Mohammed. I'll read it out loud. I know you can see it. It says, we are facing corrosion in CRA material on I don't know what that means, in Conley 625. Can you explain what is the issue? I don't know if that's enough information for you to digest, or if you'd like to maybe reach out to Mohammed afterwards and talk about him directly.
Absolutely. So my information is going to be posted up at the end of the talk here. So Mohammed, I'd be happy to get back to you if you send me an email after the talk. Be happy to get back to you on that. Just need a little bit more information on that.
Okay, sounds good. Yeah, no, that's great. I think that's the whole purpose of this. Just moving on, you kind of talked about people using sealants or lubricants or things on the face of the gasket to get it to correctly seat. I know that this is an example of probably what you should not do. Is that correct?
Yeah, 100%. So a lot of the times, if you have a spool application where, say your valve didn't show up in time, you need to put a spool in place. Well, operations will usually put a sheet gasket in place, a low-cost sheet gasket. Well, they might put pipe dope onto the flange face so they can stick that gasket on, and so it'll either stay in place, but as well can be removed easily. After that spool is taken out and the flange put back in. What you need to understand is when that is done, well, that gasket is compressing against that pipe dope, which is then pressing against that flange face, and it's creating a hydro, and which can potentially cause minor leak paths.
Right.
So it's definitely not recommended.
I know that this is a huge slide and there's a lot on here. Let's just quickly talk about just the quick guidelines that you want to go through when you're making sure that you have a good solid connection. Yeah,
so these are just rule of thumb kind of best practices that I follow when I'm installing a gasket personally, and we can develop help develop these standards for end-to-end user, given the application or what have you. But these are kind of the basic rules that should be followed. Stop and look, take a look at the application, the different pipes, flanges, so on, best practices, clean flanges, and so on. So it's all labeled out there for you, but it's important to follow these. If these key points are followed, you should have no problem whatsoever sealing that flange connection.
I also want to point out to everybody that's listening, if you do want a copy of this after the fact, please just reach out to me, and I'd be more than happy to send it along.
I was going to say, Joe, maybe we could cut this slide out and even post it too, just separately, even from when this.
Yeah,
this is recorded.
I
think this is really good. Yeah,
that sounds like a great idea for you.
I'll just screenshot it. Let me Ted do it.
I'm going to move on to the next section, which is Chad's favorite. Just really quick, let's talk about lubrication, why it's important, and why we need to do that on our hardware, specifically the studs, bolts, nuts, things of that nature.
Yeah, so applying lubrication is very important on how you apply the lubrication, but as well knowing what lubrication to use. And a lot of in the industry, a lot of people. The importance of torque and making sure that the torque is correct and applied correctly and so on. So next slide, if you can there, Joe. So when you look at torque being applied to the fastener and the bolts lubricated or not lubricated, here's a quick little indication on how proper lubricated fasteners can help achieve that load. So when you take a look at a 2-inch B7 stud torqued at 50% yield, no lubricant, you're looking at a little over 6,000 foot-pounds of torque applied to achieve that 50% yield.
Wow.
Moly lube on just the threads only, just over 4,000 foot-pounds. Moly lube on the face only of your nut, that's a little less than 4,000. Moly lube on the thread and the face, just under 2,000. So it kind of shows you that there's a significant, decrease if that lube is applied correctly and where it is. Also like to point out too that a lot of end users, a lot of companies, they apply their nuts and their fasteners without washers, and this is a kind of a key point where I personally have a challenge with.
Is that good or bad, Sean? Is that
leave it up to the masses, because you take a look at your fasteners and your nuts. And without a washer, that nut is resting against the flange face, right?
It's like magic. Where'd you get that from?
That nut, it's pushing against that flange face, and what's on that flange face? It is paint.
So,
right. So what you're doing is you're wrecking your beautiful paint job that summer student worked so hard on painting that flange, but as well, you're creating resistance. And that's how the torque is measured, right? That torque's measured by resistance.
Yeah.
So if you have a little bit of paint on one side of the flange and a lot of paint on the other, well, you're going to have differences, right? So potentially your fasteners, each individual fastener is going to have different loads on each one. So how you correct that is having a nice clean washer with lubricant on the backside of the nut, lubricant on the threads of the fastener, and you have a nice clean applied torque on that fastener.
I'm shocked and surprised that a lot of people do not use the nut there. I just assumed that was kind of a standard. All right, I'm sorry.
The argument, Chad, is that there's a machine surface on the back side of every nut.
Yeah.
And that that machine surface is resting against the flange, and it's creating a nice smooth transition. But we all know that a lot of there's the machine surface on that nut, right? But we all know that the majority of the flanges out there are painted.
Yep.
So it boggles my mind where a lot of the engineers and operators are, very persistent. You gotta have the right torque applied to that fastener. You have to have the right torque factors. But as you can see up in the slide here, the different types of lubricants have different nut factors, K factors.
That's crazy.
And that affects the torque applied to that fastener as well. So if you're using, your standard Molly B lube, which has a K factor of 0.13, well, and you're following a specific torque for that 0.13, and then, the next flange, it's an isolation flange, and you're using our non-conductive lubricant, and it has a 0.19 K factor, for a certain torque value, well, you're not going to have the right loads on that flange connection.
And I think, I'm trying to summarize all of what we're saying, but the reality is that you have to be cognizant and be responsible in every facet of what you're doing to make sure that you have the proper setup. Even as something as simple as the lubricant on the threads, and then even taking a subcategory of that, of where you put the lubricant on the, so
there are things people take for granted, right, Joe? I
think so. And I think there's a lot to be learned from this, is that, it might take a little bit more time and it might cost a little bit more, but if you want it done the correct way, you really need to focus on the important things, as simple as where to post lubricant on.
And you know what? When it really comes down to it, Joe, it's education, and educating your operations crew, educating engineers and so on. And if the listeners contact Joe and Chad, I'd be happy to come out to your offices or sites and put on a talk to educate your operations crew on different areas of the flange connection, and helping them understand kind of the factors and so on.
There's one last one that we have, I think, or actually a couple more slides, but this is another big one that we could also post. But we talk about this a lot in the clamp load and the things that you need to look for in doing that. If you could just touch on this quickly, Shawn, for everybody. And again, this is another one that we can probably post online for people.
So, like we've been pointing out, there's a lot of factors that come into play with the flange connection. Friction being one, and probably one of the most important, is to get that proper clamp load down. The different tightening methods, be it your standard torque wrench, or operator just using a regular box end wrench, tensioning devices and so on, but also relaxation of that flange and so on. It's all very important to understand the key components of that flange connection, making sure that it's done right and so on.
Yeah, for sure. Last couple slides here, just engineering availability and talking about protecting your assets.
Yeah, so like I've been pointing out, there's a lot of different products out there. There's your standard basics and so on, but if you have different applications that you're having issues with, that you don't see something essentially on Lamons' website or Chad and Joe's website, what have you, we can come up with something. We can come up with an alternative product. We have a full-on engineering crew, and able to assist you in at any facet. So more or less just willing to lend a helping hand and help you guys out, get up and running.
Yeah, I think you're hit the nail on the head, and I think the last few slides are really important. Just pointing out the fact that there are ways to do this. There's proper ways to do it, and it's just the education and keeping everybody in tune with what and how to properly, and safely do a job. And
right.
As we kind of talked about briefly with the emissions and things like that, there's going to be a bigger push on making sure that things are bolted correctly and that they're not leaking, and some of those maybe loose ends that we've had in the industry in the past are kind of tightened up. So, I just want to say thanks, Shawn. I know that you're trapped up in Canada, and I hope everybody is safe and happy and healthy with your family and all your friends up there.
Thanks, guys.
It's a weird time. We really appreciate you doing this for us and with us with the expo, and you're a good friend of ours, and just can't wait to get to see you back.
I know.
Hopefully,
Miss you, man.
sometime soon.
Yeah. And I'm just wondering where Ted is with my beer and chicken wings.
I got rid of your Kia too.
It's a whole different story. So I'm going to end this now. Thanks everybody for attending. Shawn's email address and contact information is on the screen. So if you want to reach out directly to Shawn about any potential questions,
Or either of us.
yeah, or Chad or myself, we don't know anything, but we'd be happy to pass it along. And stay tuned. 2 more weeks, we're going to be doing another one of these. So I hope you guys find some value in it, and we'll keep plugging along.
Thank you, Shawn.
Joe, Jad, appreciate it.
Thanks,
Thanks.
buddy.
Take care.
See you guys.